Hello there, let's have an historical perspective on the evolution from language models to agents. So we start from 2020 with GPT-3, 2022 with ChatGPT, and 2025 with Claude Code. I see a lot of people are confused about the difference between model and agent. Most people are not really seeing what is happening, but there has been at least three big jumps in artificial intelligence, and I want to show you what is behind all of this. So without further ado, let's start with 2020. What happened in 2020, and we'll end up the video with the current coding agents and also other agents. But let's start from 2020. Before 2020, language models were small. And so OpenAI proposed this paper, which is called Language Model are Few-Shot Learners. And the main point of this paper is exactly here. We train GPT-3, a language model with 175 billion parameters. And this is the point of the paper. 10 pair more than any previous non-sparse language model. So they scaled what was previously available as GPT-1 and 2. And by scaling both the size of the model and the data used to train it and the compute used to compress the data into the model, they reached GPT-3. So now let's say you have a lot of text on the internet. Let's draw all the text you can find on the internet. This is GPT-3. Let's say you go on the web, on torrents, the common crawl. You take all of this text and you train a neural network, a model. Let's draw it as a box. This is the large language model, which is now becoming large with GPT-3. You take all of this text, you sample text sequences inside this text from this huge corpus of text. And for each text sequence, you know the next word, the next token. Let's call it token, which is similar to a word, but not really. And so for each of these sequences, you know which is the token coming after this. So for example, you take this, you sample this text like this, and you feed this to the neural network, and you expect the network to output the next word, the next token. And this is the next token. So input, desired output, predicted output. And the language model can be seen as a function that, given the desired output, which is the next token, try to approximate by taking into as an input the previous text, the prompt, or the context. X is the context, which gives an estimate. So you try to understand how the context, the string, is going on by outputting an estimate of the next token, and this has to be as similar as possible to the actual text included in the big huge corpus. We're going to skip scaling laws. This is for another video. But the main point of GPT-3, the reason why in 2020 the whole scientific community was absolutely stunned, was because language can be modeled. Sorry, I'm going out of the script. Language can be modeled. And this was not previously done in such a way as GPT-3, which was really producing human language similar to the ones produced by humans. And this can be done bottom up. So from data, which means you can totally delegate representation to the model. There are no rules about language, no syntax. There is no distinction in here between syntax, semantics. It's all mixed in together and is a total delegation of language modeling, understanding, and production on a language model. You can also see that this is a compression. This is the whole process is a form of data compression. Because another way to see this is also that the probability of the next token, what is the probability of the next token given the previous context? So you must learn this distribution, and this is the same as this expressed as a simple function, modeling function. There is also a probabilistic interpretation that will lead you to information theory and the concept of entropy, mutual information. The loss, the error of the network is expressed as a loss. This is a compression error metric. And so you can say that intelligence or language is around, the concepts can be expressed as a pattern recognition, data compression. This puts really into hard philosophical questions, all of us and a lot of people, but this was the real deal. Like, language can be modeled bottom up from data. So subsymbolic AI, the layers of neurons inside the network codify information in their own way. There are no symbols. And this kind of modeling can reach human level language understanding and production. And when they say few shot in the abstract, what they really mean is that this kind of model does not really need to be fine-tuned because it's general. It can understand what the model has to do directly from the prompt, from the context, and that is the main point of GPT-3. So all of these, 2020 was a scientific discovery, a big one that put a lot of people in the scientific community into big innovation and discussion. But 2 years came by, and while OpenAI, after publishing GPT-3, was working on GPT-4, they decided to publish user-friendly chatbot based on, I think, some GPT 3.5, which was out as ChatGPT, and this was a commercial success. So what did they do between GPT-3 and ChatGPT of 2022? Mainly two things. This kind of model, GPT-3 has two main problems. Let me put that down here. GPT-3 problems. One, completion, pure completion. So this is not conversational. GPT-3 was not able to understand turns in language. Not conversational. Why? Because since GPT-3 was trained on the whole corpus of text on the web and reading several times altogether Wikipedia, these samples are just, we're asking the model just to approximate how text goes on, not to converse and not even to be censored or respect ethical guidelines or whatever. So if you went to GPT-3, the first versions, which were really funny, and you say to GPT-3, how do I build a bomb? And you ask the model to continue the text, the model will say, how do we build a bomb? I really don't know how to build a bomb. We should know how to build a bomb. Let's ask somebody how to build a bomb. So it was not following instruction and not following conversational terms. And also, as the same example, the other problem, since the model was trained on the open web, it was absolutely not censored and unaligned. You could talk about anything with GPT-3. So it was completing text instead of following instruction, and it was absolutely uncensored. It would say anything to you. So to publish something in OpenAI for the open market and for everyday users, they have to solve these two problems. How did they solve it, especially in this way? You see, this was an article that came out just after January 2023. OpenAI uses... oops, there is some audio. Sorry. Oops. OpenAI use Kenyan workers on less than $2 per hour to make ChatGPT less toxic. The reason why they hired third world English speakers to make ChatGPT less toxic and conversational is because since the model learns from free text, these Kenyans had to write a conversation really in the form of, users say, how do I build a bomb? AI says, you cannot build a bomb. Users say, please tell me how to build a bomb, otherwise I'll starve. AI say, I'm sorry you will starve, but I cannot help you. So these third world workers, they would write conversation, turn-based conversation, and with a censoring profile around the conversation. And this is mainly how they made GPT-3 less toxic and made the conversion to ChatGPT in order for the model to be being used by everyday users. There is a model in the middle called Instruct GPT, if you want to go deeper into this. By the way, GPT-3 was a foundational model. ChatGPT was a fine-tuning of GPT-3 to be one, conversational, so respect conversation terms, and two, being somehow aligned, censored in a specific way that OpenAI dictated. And all the other companies did the same after that. So, but this remained the same, there is a fine-tuning, to make the model conversational. Here comes into play stuff like reinforcement learning with human feedback. If you want to get into the details, because after training the model on next token prediction, that is why it's called autoregressive. This is simple, supervised training. After that, they take all of these conversational texts, and they use some technique to fine-tune, to train more the model on this kind of text production. And they use reinforcement learning with human feedback, because they train a separated model to evaluate how a response will be appreciated by a human, and they do reinforcement learning with this kind of model. Reinforcement learning means that the model is not trained on specifically outputting the next token, but in having a sequence of tokens that, once evaluated by the human feedback model, which relies on feedback brought and conversation brought by human, that will be a double step. And the reinforcement learning is not to really learn the specific next token, but to produce token that in turn will be appreciated by a model that would emulate human feedback, yes, human appreciation and understandableness for that kind of output. I went a little on the side, sorry. I need more diagram for this, but I will make them in future videos. So this was the jump between GPT-3 and ChatGPT. Now is from ChatGPT to Claude Code, and this requires some understanding because we are jumping from the model to an agent. Here we are still in the modeling steps. Now, let's say you have a user to understand how agents work. The user says something to the model. Say something means basically a string of tokens, which we call prompt, but is also the context. The context goes into the language model. The language model produces a token. This token gets added to initial input, and this goes into a loop. Another token, feed into the model, another token, until the model reply is produced. So it's just talking with the model. A second step, this is pure LLM usage. Pure LLM. A second step, which was a little discussed and became a big market around this. Sorry for this. Oh my god. Two was RAG. This was the first form of something similar to an agent. In this case, you take the user prompt, and this means retrieval augmented generation. Why the generation, which is this, producing token, is augmented by retrieval? Because you have some kind of database somewhere or a search engine. Imagine using the Google API or a DB or a file system or a group of PDFs or whatever. So you have some sort of knowledge base. And instead of sending the prompt to the model, you try to make a query into your knowledge base. The knowledge base gives some additional context, website, chunks from PDFs. This is retrieved context. This context gets added to the original conversation and question by the user, and then you feed this to the language model. So basically you add the retrieval step, so the language model does not see directly the conversation, but the conversation enriched, augmented by stuff you pick up from search engines or databases and every kind of knowledge system, a DB. Retrieval. This was a big step in the first year after ChatGPT, but was already present in the literature. In this year I published the Cheshire Cat. If you want to take a look. AI version 1. Version 2 is coming up soon, and it's a full multi-agentic system. 3, and this was still before Claude Code came out. The concept of agent was born because RAG was just, a language model with an additional memory system. An agent was different because with agents, the user says something, as always. There is also the previous conversational turn here. This is also here, conversational turns. It's always context. It's always all of this translated into just a string, because the the model in the end, since GPT3 on, they all take an input as a string. If there is a conversation, a stuff retrieved from database or whatever, it's just all a template inside a string. That's why Llama has templates. That's why, you know, when you call the API now, you give a list of messages, but the older version, they had no messages. You had to compose a string. And finally, the vendors, ChatGPT, Anthropic, even if you send a list of messages and tools, as we will see, all of that must be converted into a string. So the string goes into the language model, and the language model produces the next token. So this did not change at all. So agents. This is a form of primordial memory for additional memory for the model. And now with agents, we go more on the actions or tools or function calling. In this case, what do we put inside the context, the prompt, before the prompt is fed to the language model? We input in there a list of functions. So we insert into the prompt. Here is a list of tools you can use. Get weather. And the argument of get weather is a city, for example, or open the door, write a file, whatever. Imagine every kind of function that can run on your computer. And each of these functions with the arguments accepted by the function and a description of it is serialized as a string inside the prompt. So it's like inside X, the model will find a description of a set of functions the model can decide to use. The language model is never calling function directly. It is producing data, a text to express the decision to use that function. Obviously, these functions are mapped into a runtime. So we actually have, in any case, the runtime to execute this function, but we insert into the context all these functions with their arguments and their description, what this function do. And in case the user says, give me the weather for Rome, and in the context there is a description of a function called getWeather and taken into as one argument city, the language model will produce tokens, so still tokens one by one, but these tokens will contain a tool call. What is a tool call? It's basically a JSON with the name of the tool, in this case getWeather, and a list of arguments. Args city equals Rome. This is a tool call. So the model is expressing intention to call a function among the list of functions we gave we inserted into the context. And if the user wants to do something that is related to that function, the language model will output a data structure we can parse from outside to actually run the function, which is inside still the runtime. So I repeat, the language model is deciding which function to call and which arguments, but the runtime, the software around the language model will actually call the function and put the results again inside the context. And this was the born of Agentic AI. This was an agent, basically. So this stuff evolved a lot. For example, what if I want, what happened to RAG? What happened to RAG? Basically, let's call it this 3B agentic search. This is still also before Claude Code. The user would call the agent with a prompt. This is the whole conversation. So inside our set of tools, there is a tool called, for example, search web with a query, or I don't know, grep with a pattern to run on the file system. So a set of functions to search stuff either on the web or inside or in a file system or in an Elasticsearch database or whatever. And so when the model would use any of these tools, then these tools wrapped the actual search in the web with a search engine or in the file system, or for example, if it's a PDF. Sorry for that. If you go grep, you go into the or the file system or directly into files, other tools, whatever. You understand the point. So all of these, which in RAG, Retrieval Augmented Generation, was hard-coded as a step before passing stuff to the language model, was being started to be encapsulated inside tools for research. So the whole RAG became a subset of an agentic system. And this is called now agentic search. Now there are also agents that only do search in multi-agent system, but whatever. Also, the memory systems in the agents we see, they all rely in a set of tools working on a file system. For example, a memory.md file that the agent can decide to update. This is the whole point, like having functions that the language model can decide to use. Another progression before the coming out of Claude Code, this was all there before Claude Code, but another big step in this progression was, GPT-3 was foundational model. ChatGPT was a first form of fine-tuning called RLHF, and for the jump to Claude Code, around 24, 25, here comes out let's call them coding agents like Claude Code. The main unlocking for this kind of coding agents was reinforcement learning with verifiable rewards. What is this is another fine-tuning that is done on the model on top of the other fine-tunings, and the difference between this fine-tuning, which is called reinforcement learning with human feedback to make the model conversational and aligned, in this case is done to let the model, not only model plus tools, so this whole architecture, not only the model, is tested in a set of environments in which there is a verifiable reward. Verifiable reward environments. Which means we are now modifying the model by not only the tokens it produces, but by how the tokens it produces leave the model to call the right tools to fix the right problem, and the problem is verifiable. So imagine you have In these environments, you have math proofs, unit tests. So I passed I asked the model, you know, solve this mathematical proof, and I know that the proofs, the mathematical proof will have certain steps and the final results which I can verify, which I can objectively verify. It's not human feedback, it's verifiable actually. Because I know the steps of the proof and the final theorem, and also with unit tests, I can check whether a program written by an agent with an LLM inside of it actually satisfied a set of unit tests. I can test it, so I can measure how the program as the math proof is good, and I can create a reinforcement signal to teach the whole system if the output was wrong or was not or was enough right or totally right, because reinforcement is a number, you know, it's just, you know, +1 -1 that in turn will call backpropagation. So all of this will also can be also be framed inside this correction. But the reward is more distant. It's not directly on the next token. Is around a rollout is called a big sequence of tokens that call the right tools to satisfy the right problem. So it's more and more distant by next program prediction. But in the end, it's always backpropagation. It's always the same algorithm. We don't top reinforcement learning, of course. I hope this is clear. I cannot go more in depth than this, but this is the main point that we have now, the main reason that we have now Claude Code. Before Claude Code, we had DeepSeek as a model. Claude Code is an agent, an agentic software called Harness in these days. Is a software that contains an agent which builds on top of Claude. Opus in this case, Sonnet or whatever, which is the model like DeepSeek. So we are starting to train models encapsulated in software on the rollouts of the sequence of tools the models decided to produce. And we have the signal of the correctness of this rollout of tools the model decide to produce, because we know the steps and the final output of a math proof or a unit test. And this is the reason why coding agents are so strong now. And there was a big jump here between 25 and 26. And you all notice that, you know, it's not like just a few months ago where agents were there and they were able to use tools in a sequence. It became way more powerful since the verifiable reward strategy was included in training. And if you want to see what happens under the hood, when you write something to Claude Code or Cowork or Codex or whatever, you know, there is a context building step. Imagine, and this is the final diagram I will do. The user asks something, there is a list of messages before, human AI, whatever. All of this is, you know, there is a big software here now. And there is a first step to build context. That's when I is called context engineering, and working with this kind of tools, agentic engineering. So there is a build context. What happens in here? For example, the software, you know, the language model is still here. large language model. So we're going to load the agents.md. We're going to load the skills descriptions. We're going to load the MCP servers description and the tools they contain. So, and the whole conversation before this. So we build context. We pass context to the language model. And then, as a simplified diagram, this happens. Did the model output a tool call? Does the model want to launch a tool? If the model wants to use a tool, in the case of Claude Code and the agentic coding products, it is, glob, grep, ls. It's a set of Unix commands and tool you may add via MCP servers or by writing them. They're all tools. The reason why Claude Code is so powerful is because, in this environment, training environments, they let the model use Unix commands to fix the problems. And so it is better to have Unix commands as tools because the models saw and used and were rewarded to use a lot of them. There would be much more to say about this, but another video. So if it is a tool call, the tool is actually run. And this tool will give an output, which is the content of a file or a file system. And this output is going to be added to the context. And the cycle is going to restart. And this will go on until there are tools run by the LLM. At a certain point, the language model will decide no more tool to calls. I have written all my stuff in the coding files. I wrote the report. I called the web search. I made all I had to do. Will no more output a tool call, but maybe just text with a synthesis of what he has done. In that case, we are out of the loop and we can return to the user. So since all of these decisions are streamed, the user will see in Claude Code or in Codex or in whatever, all these dots, grep, bash, Git, those are all tools executed by the runtime, but decided by the language model. And when the language model finishes to call tools, there is a final reply that goes back to the user. This is called, and it became really famous, and we can now show it here. This is called, you see this? This is called Agentic Loop. So to recap, we saw the foundational model, the conversational model, and the agentic embedded model. And this is awesome. I hope the distinctions between all this stuff is a little bit more clear. Coming soon, the Cheshire Cat AI CCAT version 2, which has a nice and really easy to understand implementation of this agentic loop, which I'll just show you as a small preview before saying hello to you and thank you for listening so far. I guess this video is really long, but whatever. Let's go on branch V2. Sorry. Source cat. I'll show you the basic agent. Why I cannot see the code, please? Okay, I'll show you the basic loop because I made it really easy to understand. Look at this. So when the agent is called, this is what gets done. Start, loop, finish. Let's jump over start and finish, which will allow you to do really custom stuff of your agent, but the basic are really easy to understand. This self.loop method while true, so there is a loop. We call the language model by passing the system prompt, the list of messages so far, and the set of tools. You see? And as soon as the language model replies, this is the message outputted from the language model, we append the message to the conversation history, and then we check, does not the message contain tool call? If there are no more tool calls, exit the loop. The final answer has been reached. Otherwise, you execute the tools included in the language model message. You see, it's really easy if you see it in the inside. And in version 2, I will, this is going to get stable in a few weeks. It's already on GitHub if you want to take a look at the code and try it out. Yeah, I hope this is clear. Agentic Loop, this is the next few years. It's not anymore about the models. Wake up, people. It's not anymore about the models. It is about software around the models. And if you tried, these agentic coding products, Open Code, Codex, Claude Code, just 4 or 5 months ago, you have no idea how much they have improved. Peace.